Hi, we're the NDSU Capstone team working with Deakin University. My name is Michael.
I'm Brian. Peter.
And I'm Nick. We made a smart navigation system using a Raspberry Pi and a GPS hat. Let's take a look at the hardware.
Taking a look at the resources we had. For hardware, we were given a Raspberry Pi 3 along with an Adafruit GPS hat that sits on top of the Raspberry Pi and outputs its current location. The GPS hat connects through GPIO pins 14 and 15 to create a UART serial communication, allowing us to read our latitude and longitude through the TTYS0 file. For software, we utilized the Kiwi libraries to create a GUI. We had the open source routing machine giving us routes to and from different locations, the MyGasFeed API to retrieve all service stations near our current location, and the Open Weather Map API for weather conditions.
Now here's what our map actually looks like. As Brian said, Kiwi was the primary UI library used to get everything shown here to actually appear on screen. It may not be too pretty to look at, but bear in mind the focus of this project was not on the UI itself, but on the functionality and assistance the map could provide for drivers. In this period of transition toward fully autonomous vehicles, this project is meant to show some ways in which navigation systems could be made smarter and more helpful to the driver than simply showing the route from point A to point B. In theory, the Raspberry Pi our map is running on would be connected to the vehicle a person is driving, and would use sensor outputs from the vehicle to determine what tips and advice it can offer the driver. This is where all the buttons on the right of the screen come in. Seeing as we couldn't actually connect to a vehicle with the resources we were given, these buttons mock the behavior of a vehicle. There's controls to add or remove gas from the vehicle's gas tank in increments of a quarter gallon, a button to toggle whether cruise control is on or off, and a button to toggle whether the driver's headlights are on or off. The controls in the top right are used to simulate driving. Clicking on the route buttons makes a call to OSRM, passing in the current location as well as the coordinates of the location you clicked. It immediately returns a route, which is drawn on the map in blue. If you press the Start Driving button, the vehicle moves along the route. Again, this was done with mock data, so we wouldn't have to jump in a vehicle every time we wanted to test our code. While driving, the Weather API gets called asynchronously to make sure you're safe on your route. Unfortunately, the weather is great right now, but if it were raining along the route, for example, and the driver didn't have their headlights on, text would appear on screen telling them to flip their lights on. It doesn't turn the lights on for them because this map is meant only to assist the driver, not take control of their vehicle. The other main use case we focused on during our project was rerouting the driver when their gas tank is low. For that, I'll pass things off to Michael.
Alright, now I'm going to talk a little bit about how our service station feature works. Right now, after we set the gas value below 1 gallon, a pop-up will appear asking us if we want to reroute to the nearest station. Upon hitting yes, the program finds the nearest station and adds it to the current route. Every few seconds afterwards, our program will check to see if there is a station that is now closer than the previous one. Maybe we accidentally passed it or decided that we didn't want to go to that one. If it does, another pop-up will appear asking if the driver wants to reroute to the new station. The program will continue to search for new stations until they refuel their gas tank or dismiss the messages.
Wow, what a demo. So, I hope that gave you a good insight to what our project was about. Just know, with good attitude and a strong work ethic, Capstone can be one of the funnest classes you'll take in the computer science department.